Hi guys, today we're gonna talk about the urinary system and different organs which is included urinary system and how they help our body to maintain homeostasis of water, salts and different nutritions. As a system, it includes not only just one organs, it includes multiple organs. The main ones obviously is our kidneys. We have two kidneys, left and right. Um, the right kidney, which is this one, is a little below than the left kidney uh, because the liver is under the kidney and is pushing it down a little bit. So the kidney have approximately the size of your fist. Each kidney has a tubulum, have a muscular tube leaving from each kidney. The name is ureterus, right? We have two ureterus, one ureter, and the urine goes from the kidney, goes through those tubes and goes to the uh, muscular muscular organ, which is called the bladder. And the main function of this organ, the bladder, is to hold the urine up to the point your brain is going to send a signal and when you're going to release the urine, right? So this is a storage of our urine. One of the main future of a bladder is it can expand like a balloon, so you can hold a greater volume of urine if you need so. And then we have at the end of a bladder, of the bottom, you have a sphincter. So the sphincter it is a muscle which is prevent the urine to go out, and you can control this sphincter with your mind, right? A cool thing about you learn how to control this sphincter when you become an adult. I mean, you learn this as a kid. That's why as small kids they cannot control their urination because they didn't learn this reflex, right? So this is a reflex. This is learned reflex. So we learn to control these muscles. We learn to control these muscles, and if our brain sends signals, so the bladder is full of urine, and you need to urinate, the sphincter is going to get relaxed, and the urine is going to leave through the urethra. Um, Females and males have a different length of urethra. Um, females have much less urethra. That's why they have high tendency to have urethra infection. This could be the most common one is a yeast infection, and this infection might go to the bladder, and for the bladder it might go to the kidney, and from the kidney it might go to the blood. So this is very serious thing, and most of the time infection most of the time the woman can get infection of a poor gigian, right? So all right. So what is the function of a kidney, right? The main function is to filtrate the waste from our blood. And what kind of waste? The waste is from our cells. Our cells all the time working, and they produce a metabolic waste. And this waste sometimes very harmful, and it has to be it has to be removed. So the main one is urea. It's a waste product formed as a proteins are broken down. So when we digest the proteins, um, ammonium is formed, and this is extremely harmful product. And this ammonium turned to the urea, and it's removed as not harmful molecule. Then we have a creatine, which is also toxic. It's a waste product formed by muscles as we use them. Also, if you eat something very salty and you have a lot of sodium or calcium in your blood, and this is gonna change the homeostasis in your body, and this is why. So we have a special amount. We supposed to have a certain amount of sodium, potassium, calcium, and magnesium in our blood, in our cells. If this ratio is gonna change, go up and down, our kidney is gonna be making sure to remove the extra of sodium or potassium. And also, if you have just an excess of water, this excess of water is have to be removed, and this water can be gained when you digest food. Or all the food have some amount of water, and if an excess of water just have to be removed. And the other portion is the toxins, which is we can digest from with food. If, for example, if the person digests the food which is not good anymore, and this food might accumulate some toxins, it have to be removed. Or, for example, alcohol, right? So when we get some alcohol, when the person gets alcohol, these alcohols have to be removed by our kidneys and liver. And also, if you take some medication and drugs, most of the time, kidney has a high rate of getting those medication out of your body. So this is why when you take drugs, you have to take them constantly. You do not just take one pill and this pill is going to be working for a couple of days or weeks. The reason why, because you take a pill and your body sees this medication as a foreign substance, so it's going to remove this foreign substance from your body, and if it's removed, you're not going to receive any medical effect from that. So that's why most of the drugs have to be taken constantly. This is what I was talking about. So when the person digests a lot of proteins, and proteins made of amino acid, and when the proteins are broken down, when you digest, for example, meat, just a food which is high in the proteins, these proteins are going to be breaking down for amino acid, and our body cannot store the amino acids, so we have to remove the excess. So when we're gonna use amino acids, for example, just for energy or for something else, those amino acids are gonna be broken down, and you have an amine group. And this amine group, when it's transferred from when the amine group is removed from single amino acids, is gonna form ammonium. And ammonia is an extremely poison, so it's gonna basically kill everything, right? It's extremely toxic. So, but what our liver can do, it's gonna change ammonia to the urea. It's gonna change the structure of ammonia to urea, and if the urea is not as toxic as ammonia, it's gonna be removed with our urea. So that's why we call, so this molecule, the main name of this molecule is urea. That's why we call everything is, for example, urinary system, right? Because it's all about this molecule. All right. So the main function of a kidney is to maintain homeostasis, right? So what is a homeostasis? Homeostasis, it's a balance of water, balance of solids, and balance of nutrition in our body. If you have an excess of water, our homeostasis is compromised. So, and then the function of a kidney to come back to right homeostasis. So if you have too little water, and your body is dehydrated, it means you have not enough water, the kidney is gonna reabsorb water back to decrease urination, and your urine is going to be concentrated. If you have too much water for some reasons, right, the homeostasis is also going to be compromised, so the kidney is going to increase urination. And also the pH, mostly pH is regulated with our lungs, but the kidney also have some control to control the amount of acid and bases in our blood. So kidney also control the pH of our blood, because pH is also a very essential criteria for our cells. If, as you remember, if pH is going to go too low or too high, our proteins is going to denature, and this may lead to very bad consequence to our cells. So let me talk about the anatomy of our kidney. So the kidney divided by three portions. This is a renal cortex, renal medulla, and renal pelvis. So renal cortex is the white portion, the right portion of a kidney. This is the top portion of a kidney, which is the main filtration happens. The main filtration of a blood happens, right? So this is the renal cortex. And then we have a middle layer, which is renal medulla, right there. So this is a middle portion of a kidney, and it has so the renal the renal medulla has a special structure, and they called pyramids. So in those pyramids we have network of small tubes where reabsorption and secretion happens of a filtrate, primary urine, and we're going to talk about this in more detail. So the first filtration happens in a cortex, right? The filtration of a blood happens in a cortex, and and when a filtration happens, it produces primary urea or filtrate. And this filtrate is going to accumulate and is going to go through these pyramids, the network of different tubes, and final urine is going to made, and it's going to go to the chylexes. This is also the structure of a kidney. The chylexes is the deepest layer of a kidney, where the urine is going to accumulate, and it's going to go to the pelvis, renal pelvis, and the renal pelvis is going to form the ureter, and then it's going to go to the bladder. So also each kidney have two major blood vessels. The first one is a renal artery and renal vein, right? So the renal artery have oxygenated blood, so the filtrate, so the blood gonna go inside the kidney through the renal artery. So this is gonna be oxygenated blood. The blood gonna go through the kidney, and the blood is gonna give up oxygen to the cells of a kidney. Is gonna take carbon dioxide back, but it's gonna leave all the waste in the kidney, right? So it's gonna give back oxygen. It's gonna take carbon dioxide, but it's gonna give all the waste to the kidney in the form urine. And the clean blood, we can call it as a clean blood, is going to leave the kidney, and it's going to be deoxygenated blood for the vein. So this is how and we're going to talk a little bit more in details how the blood circulation happens in a single unit of our kidneys. So the main unit of a kidney is a nephron. So nephron is a special structure of a blood vessels, of a capillaries, and different tubes, which are responsible for making this filtration happen. So those different structure, those different tubes and capillaries filtrate the blood. So a quarter, 25% or a quarter of our blood, of total body's total blood passes through the kidney per minute, right? So this is extremely large number, and as you can think about the kidney is extremely important function of our body. And unfortunately, when the kidney failure happens, the person has to be put on a special machine where the blood is going to be filtrated instead of kidney. And if the person is not going to get new kidneys, it's high risk the person is going to die, because the kidney is not going to be able to filtrate the blood, and too much metabolic waste from our cells is going to build up in the blood, and they're going to make that blood very toxic, and from those toxins the cell is going to die. So let's talk about the major unit of a kidney. This is nephron. That spells like this, nephrons. So we have about a thousand nephrons in each kidney. Each nephron has an afferent arteriole and efferent arteriole. So please remember this name. So the blood flow begins from the afferent arteriole, and those arteriole is going to divide to the bunch of special capillaries. So this bundle of capillaries, where the blood is going to go through these capillaries at a very high pressure, and those capillaries are isolated in a special capsule. And those when the blood is going to be filtrated, the primary filtrate is going to accumulate in this capsule in leaf, and the clean blood is going to go to the efferent arteriole. So please remember. Please remember the blood flow. The blood flow in a nephron. So we have afferent arteriole and we have efferent arteriole. The way to remember which one is, and the A goes the first one and E goes the second one. So always remember the blood flow in a nephron begins with the A, afferent arteriole, and ends with the E, efferent arteriole, and the filtration happens. So so this is how it looks like, the single unit of a kidney. So we have renal cortex where the main filtration happen. Then we have renal medulla. This is a middle layer. This is a middle layer of a kidney, which is some reabsorption and formation of a final urine happen. And then you have a pelvis where the urine is going to be made. So let's go through the little bit of structure. So in a renal cortex we have, you don't have to remember the name of all those structures. We mostly going to concentrate on a function of a nephron, or especially the glomerulus, right? So the name of the portion of a nephron where filtration happens is called the glomerulus, right? So all this is called the glomerulus, and from the glomerulus we have the tubes, this capsule which is isolate those capillaries, right? And the filtrate happens right there, and we have network of different tubes. We have proximal convoluted tubes, we have loop of convoluted tube, or loop of nephron, and then it goes to the distal convoluted tube, and then it become to collecting duct, and those different tubes reabsorption happens of a nutrition and some different solids. So let's talk about this. Uh, so okay. So so let me just go back and explain what we I forgot to mention what um, so if you're gonna recall my previous lectures, our blood is made from a solid portion and liquid portion. So the solid portion is our blood, is our cells and different proteins. So as you remember, we have plasma and blood or cells, which represents our cells. It could be leukocytes, white blood cells, red blood cells. So we have, if you're gonna take a closer look at those capillaries have very tiny space, right? And those and also in our blood. So we not only have cells, we have a different type of solids dissolved in our blood. This is calcium, this is magnesium, this is potassium, sodium, right? Just sodium, this is our table salts, and all these salts are extremely essential. The right concentration is really essential for our cells. So, and those solids are dissolved in our plasma. So so we have an efferent arteriole goes inside the glomerulum, and it's the blood and it's high pressure. So the glomerulus is going to make a high pressure, and all the liquid portion of a blood is going to moved out from that capillaries, and only solid portion of blood is gonna stay and remain, and this includes big proteins, and our cells, which is red blood cells and white blood cells. Everything else is going to be removed. Toxins, nutritions. It could be glucose, amino acids, some fats, sodium, potassium, calcium, all the different salts and water is going to be made the primate filtrate, and this primate filtrate is going to go through the network of different tubes, and these tubes are at very close proximity with a peritubular capillary network, and this peritubular capillary network is responsible for reabsorbing back those essential nutrients. So if you can imagine because our blood is very rich in a different nutrients, in a glucose, in a different amino acids, and if those nutrients is going to be just go to the waste, we're not going to uh, be able to live because we're going to be basically starve ourselves and our cells. So that's why those essential nutrition as a glucose and different solids and amino acids is going to be reabsorbed back to those capillary network, and those capillary network is going to make to the renal vein and going to leave through the kidney. All right, so we have renal artery which is going to enter the kidney. Those renal arteries going to divide to the afferent arterioles, then it's going to go make those glomerulus. From the glomerulus it's going to make efferent arterioles, and then from the efferent arteriole it's going to make the peritubular capillary network. The reason why it's called peritubular because those capillary at very close proximity, they sometimes is even physically touching those tubes. The reason why to reabsorb all those essential nutrients back to the capillary and make a renal venule and make the renal vein, and then it's going to leave the kidney. And the last portion of this tube is going to be collecting duct, where the final urine is going to form, and this final urine is going to leave to urethra. From the urethra is going to go to the bladder, and from the bladder is going to leave through the urethra. So please note this. Please note the blood flow of a kidney, and please note the urine flow through the urinary system. So we have kidney. So we have a kidney. No, first of all, we have a blood. When we have a nephron structure. From the nephron, we have a different tubes. It's a proximal convoluted tubes, distal tubes, loop of Henle. Then we have collecting duct. From the collecting duct, we have the urine is gonna go to the urethra. From the urethra, it's gonna go to the bladder, and from the bladder, is gonna leave through the urethra. So please note this. This is gonna be in a quiz. So as I said, the glomerular filtration, the small molecules is going to be filtrate. This is amino acids, glucose, water, and salts, and also urea. And in a tubular reabsorption, right? In a tubular reabsorption is right here, because those tubes right now have those essential amino acids, glucose, and salts. So those they're gonna reabsorb back to those capillary network. Amino acids, glucose, and so on. So it's going to go to the blood vessels and back to the blood system. So please go to this diagram, and this diagram is going to show you where the essential molecules is going to get reabsorbed back. So for example, in the first portion of a tube, the water is going to be reabsorbed back. So, and let me just explain how this works. For example, and as we have an organ, kidney, right? These organs have to be controlled, and most of the time, most of the organ controlled by hormones, and the kidney have different types of hormones, which is and we're not gonna talk about the hormones because it's not the purpose of this class. But the kidney has a very precise, extremely precise control by hormones, and if you have too little water in your blood system, too little water, right? So the special hormones is gonna be released, and they're gonna affect how much water is gonna reabsorb back, right? So we have a primary filtrate which is gonna go for the first portion, and the water is gonna reabsorb back to this peritubular capillary network. Chloride, sodium is gonna be reabsorbed back too, and then in the second portion, of ascending lip, essential solutes is going to be reabsorbed back to the is going to be happen right there to the capillary network, because those capillaries are located to very close proximity to those tubes. And the final I will call it as a checkpoint of our urine system is going to be collecting duct. So if it's too much water, if we consume too much water and our blood is a little bit kind of dissolved and diluted by water, the water is not going to get reabsorbed by our blood system, right? If we have too much water and our body in a state of dehydrated states, all the water is going to be reabsorbed back. So the kidney contribute to homeostasis to regulate the salts and water balance and maintain the blood volume. And this is extremely essential for cells. If it's going to be too much salts, or if it's going to be too little salts, it's going to affect how our brain works, and how electrical signals are contributed from one neuron to the other neuron. So if this balance is compromised, our brain cannot work properly, and then the whole system is going to be compromised, and this is my lead to the death. So let me just one more time kind of go over to the urinary system. So we have two kidneys, we have two ureters, which is transport urine, which is going to form in a kidney. We have each kidney have two major blood vessels. The renal artery, which is going to bring the oxygenated blood, and this oxygenated blood has also different toxins and metabolic toxins. This blood is going to be filtrated and is going to give up oxygen and is going to take carbon dioxide from the cells, but it's going to leave all the toxins. And this deoxygenated blood is going to move out from the kidney through the renal arch vein, right? And then that is going to enter to the inferior vena cava and is going to go to the heart. Through the urine, the final urine which is formed in the kidneys is going to be transported through the two tubes, muscular tubes, and they call ureters, two ureters, and they're gonna enter to the urinary bladder. So the bladder is a muscular organ, hollow organ, which is act as a storage of a urine. And when and also remember, this bladder can expand as a balloon. So if you have an excess of water, and if you make a decision to hold urination, this bladder is going to expand. So when the bladder cannot expand anymore, your brain is going to send the signal, the same as we have a special reflex, essential reflex, right? So if you're trying to suffocate yourself, what I'm saying, if you're trying to block your if you're gonna try to not breathe at that one point, you're not gonna have enough oxygen, and you're gonna remove your, like, if you want to try, you can try to hold your mouth and hold your nose and try to not to breathe and see what happens. So basically you cannot suffocate yourself, because your brain is gonna send you a signal, oh, what are you doing? I have to breathe. So the brain is gonna send you the signal, and you're gonna remove your arm involuntary. Even though you're gonna hold it, you cannot choke yourself. Your brain is gonna send you a signal. It's gonna say, you're an idiot, I need to leave. The same is gonna happen with the urination. You cannot hold urination forever. At some point, when the bladder is gonna get full, and you cannot hold anymore, the brain is gonna send the signal, and the sphincter, which is between the bladder and urethra, is going to be open up and relaxed, and all the urine is going to leave through the urethra. So this is a good chart to kind of know the level of level of hydration you have. So the lighter color of your urine is better. So it means you're in a healthy stage, and and also if it doesn't smell bad, it means, and if it's also clear. Sometimes, if the person have a not clean, if the blood is kind of not the blood, I'm sorry, if the urine is not clean and you cannot see the through the urine, it means most of the time it means that person have some kind of infection. Most of the time it is just a simple yeast infection, and if your urine is going to change the color from the light yellow to dark yellow or even orange, it means you have a severe dehydration. And if you have a severe dehydration, it means you cannot. So if you don't have enough fluid to urinate, you're not gonna properly, and you're not gonna be able to remove toxins from your body, because you have to hold some fluid in your body, and this toxin is gonna be is gonna compromise the different organs. And the first organs which is going to be compromised, this is your liver. And at this point the person has to take a bunch of water if he wants to be alive. And if at one point from the light yellow to the orange, the urine is going to change to the pink, it means you have presence of blood in your kidneys, and it means you might have an infection in the kidney, or the kidney just not working right. And the first signs, you have to call to the doctor as soon as possible, because if you're gonna have the kidney failure, after the kidney failure you have a liver failure. And if that person is not going to get medical attention, it's a very high risk that person is going to die. So on a quiz, make sure you know the name of different organs which is make up urinary system. This is kidneys, ureters, urinary bladder, sphincter, and urethra. And also make sure what happened in this chart, right? Also know the blood flow. Through the glomerulus, and know what kind of molecules got filtered first, and what is stay inside the glomerulus, right? So the liquid portion is gonna leave, the solid portion is gonna stay. So please know what is a liquid portion, what is solid portion, and this is gonna come up in a quiz. All right, thank you very much.